each expression. Chapter 8, Section 2 notes. Dig them out. Each of these questions that I have on the board are written in scientific notation. If I take 6 times 10 to the 4th power, I'm saying I have 6 times, there's going to be 4 zeros behind it if it's 10 to the 4th power, right? So it'd be 6 times 10,000, which would be how much? 60,000. Now, if I needed to get that decimal back by that 6, I'd go 1, 2, 3, 4 places backwards to get 6 times 10 to the 4th. If it is greater than 1 or greater than 10, it's a positive exponent. If it's less than 1, it's going to be a negative exponent. Okay? It's one of the easiest ways to remember. So like in this one, I have 7 times 10 to the negative 2 power. This is like saying 7 times 100, or 10 to the negative 2 would be 1 over 10 squared, or isn't that also the same thing as 1 over 100? Right? They would all mean the same thing. They're all interchangeable with each other. So in this case, if I've got 7, picture your decimal going the other direction. So if it's here, you're going to divide by 2, divide by 10, divide by 100, makes it 7 hundredths. Isn't 7 times 100 7 hundredths? Yeah. They're interchangeable with each other. All right, let's get into our notes here. Scientific notation. At the top of your page, you have a times 10 to the nth power, where n is an integer, and 1 is your number is between 1 and 10. Okay? So what this really means in normal language, you're always going to have 10 times something for a power. Okay? There's always going to be an exponent. It's always going to be times 10 something. The number that you're multiplying by has to be between 1 and 9 something. Or 1 and 9.999999999999999. You got the idea. Okay? There's only allowed to have 1 digit in front of the decimal point. And that 1 digit in front of the decimal point cannot be a 0. So I could have something like 1 times 10 to the 1st power. Well, what is 10 to the 1st power? 10, and 1 times 10 is 10. So the smallest number that can be put in scientific notation is the number 10. We use scientific notation generally for very, very large numbers, like the distance between planets, the distance between a planet and its moon, the distance across a universe. But it can also be used for microscopic sizes. So if I have a negative exponent, it means that it's super, super tiny. This could be the measurement of a piece inside your cell phone. It could be the size of a cell. It could be the size of something inside of a amoeba, for example. Okay, they're tiny microscopic pieces. Scientific notation is a universal language, so this is not only used here in the United States, but it's used between mathematicians and scientists all over the world. So is each number correctly written in scientific notation, and explain why? Look at A. Is that correctly written in scientific notation?
No.
No, it's not. Why?
Because it has to be a number.
So no needs to be what?
Negative power.
Huh?
I don't know.
That's definitely isn't that the 4? The decimal has to be between 4 and 6.
Right. This number, the decimal would have to go where?
4 and 6.
Right. So there needs to be a decimal between the 4 and the 6. We can't say 0 point something. We can say 1 point something, but we cannot say 0 point something. Is B correctly written in scientific notation? Yes, it is. You've got a number between 1 and 9 in front of the decimal, and it doesn't matter if you have a positive exponent or a negative exponent for this one. So yes, it is correctly written. How about C? What? No, why? What?
I don't know.
I don't know what you said. So you might have been correct, I just didn't hear you.
One number in front of the decimal.
Yep, you can say only one number in front of the decimal. What else? How else could you have said that same thing? Between which two numbers would the decimal have to go? Right, decimal needs to be between the 1 and the 3. So either one of those would be good explanations. Next, write each number in scientific notation. So between which two numbers in A should I be putting the decimal in scientific notation? The 2 and the 3. So then you're going to write 2.34. You do not worry about all of those zeros. So then we have to say times 10 to something. How many places is that decimal moving over?
6.
Not 6.
7.
Not 7. 8. The decimal's here, correct? So 1, 2, 3, 4, 5, 6. Where am I going? Between the 2 and 3. So we're at 6, 7, 8. Positive 8th power because it is greater than 10. So the decimal came in 3, 6, 7, 8 because we're going between the 2 and the 3 when it's correctly written in scientific notation. How about in B, between which two numbers does that decimal have to go? 6 and the 3. Now it's going to be a negative exponent for times 10 to the exponent because we are less than 1. How many places is it moving to the right? So negative 5 would be correct. Questions there? Write each number in standard notation. So now we are in scientific notation. Is it correctly written in scientific notation? Yes, it is. We need to write it now in standard notation. So your decimal is right here between the 2 8s. How many places, Carter, does that decimal have to move? Has to go 4. So I'm going to get 4 times, or 10 to the 4th power. 10 to the 4th power means it's going to get 10,000 times larger than what it currently is for a number. So if my decimal is here, you've already moved it 1, 2, 3, 4. Fill in zeros in those blanks. Now, double check your answer. If it's 10 to the 4th power, can you go back 1, 2, 3, 4 and get between those 2 8s again? Yes, you can. So your number is 88,000. And if we're representing an elephant's mass, 88,000 kilograms. If we're talking about the mass of an ant, so here's my 7 and 3. Now we're going to be getting bigger or smaller if we have a negative exponent, Caleb. Smaller. So which way is the decimal going to go, everybody? To the what? Left. To the left. How many places? 5. So your decimal's between the 7 and 3. Going one place to the left puts it in front. And then I got to go 2, 3, 4, 5. Where I stop is my decimal. So then I have to fill zeros in all of those places, including in front of that decimal. Now, you should be able to check your work to see if you did it correctly. Just put your back at your decimal. Go to the right 5. 1, 2, 3, 4, 5. Did you get back between the 7 and 3 when you did that? What's my label going to be? Kilograms. List the planets in order from least to greatest from distance from the sun. List the planets in order from least to greatest. Let's put these in. Do we need to put them in standard notation?
No.
Okay, do you think you can do it from least to greatest without putting them in standard notation?
Yes. No. No. Yes. No.
So think about this. If this is 10 to the 8th power, it's a 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros behind it, right? No. 10 to the 8th power would have 8 zeros. So the more zeros it has behind it, the bigger it's going to be for a value, correct? Are they all written correctly in scientific notation?
Yes.
Okay? So if I'm supposed to go from least to greatest, what should I be looking for an exponent?
The biggest one, or the smallest one.
The smallest one. So I'm looking for the smallest exponent then, aren't I? So which one has the smallest exponent? Earth and Mercury. Now, which one would be smaller? 9.3 times 10 to the 7th or 3.8 times 10 to the 7th? 3.8. So list the planets in order from least to greatest in their distance from the sun. That means Mercury is the closest to the sun, followed by Earth, then which one? Jupiter, because that's 10 to the 8th power. And the farthest would be Neptune, because that's got the biggest exponent. So they don't have to be put in scientific notation. The smaller the exponent, the smaller the number. The bigger the exponent, the greater the number. Order from least to greatest. Now, if I had to order these from least to greatest, is this as easy to do if they're not all speaking the same correct language? So this time we probably do need to put these in standard notation for each one of these, or at least getting them all speaking the same language. So do you see how we have 4 different numbers that we are dealing with? So let's start with our first one. 63 10,000ths times 10 to the 5th power. Which way is that decimal going to go?
To the right.
How many places?
5.
5. So 1, 2, 3, 4, 5. What value does this become?
630.
630. 6 300ths times 10 to the 4th power. Which way is the decimal going to go? How many places? 4. So we've got 1, 2, 3, 4. 6, 0, 3. And then 2 places beyond that. 60,300. 6,103 is already done, correct? And 63 1/10 times 10 to the 3rd power. 1, 2, 3. Would be 63,100. Now, if they're all speaking the same language, can you put them in order from least to greatest? Yes. How are we writing those numbers in our list? In standard notation or the way they were given to us in the question? The way they were given in the question. We're going to use standard notation to help us get them in the correct order. So do you all agree that 630 is the smallest? Okay, but we have to correctly write that number the way it was given to us in the question. And then I can cross it off that I've used it. Which one's next?
6,000.
Okay. Then,
60,000.
so 6 3/100 times 10 to the 4th power. And our largest is 63 1/10 times 10 to the 3rd power. Always written the way they gave it to us in the question. Okay? Next question. Simplify each answer using scientific notation. We have 6 times 8 times 10 to the negative 4th power. Let's just multiply 6 times 8. How much is that?
48.
It's 48. Now, is 48 times 10 to the negative 4th power correctly written in scientific notation? No, it's not. We need to get that decimal between the 4 and the 8. So how is that going to affect our exponent? Let's put this in scientific note, or let's put it in standard notation for a second. 48 times 10 to the negative 4th power. Right now the decimal's here, correct? So 10 to the negative 4th power would be 1, 2, 3, 4. There's my scientific notation, or my standard notation. Agreed? So if I have to write this back in scientific notation, and it has to be done correctly, my decimal is here. Where do I want the decimal to go for correct scientific notation? So 1, 2, 3. Correct? So it'd be 4.8 times 10 to the 3rd power. Kind of close. Negative 3rd power. We moved the decimal point one place closer. So follow with me. 48 times 10 to the negative 4th power. My decimal was here. Grayson? Or 48 times 10 to the negative 4th power. If I went to standard notation, I'm making it smaller because it's a negative exponent, right? So 1, 2, 3, 4. That's standard notation would be 0.0048. But if I want to go back into scientific notation, don't I need the decimal to go between the 4 and the 8? So it went 1, 2, 3. So it's 4.8 times 10 to the negative 3 power. Because it's a number less than 1. If it was 40,000, then it'd be a positive exponent. But because it's a negative exponent, it's a number less than 1. Okay, let's do this next one. 3/10 times 1.3. 3 times 3. 9. 3 times 1. Do I need to do a whole other row of numbers? We don't, do we? How many numbers are behind the decimal point? 2. So don't both of those numbers have to be between the decimal or behind the decimal? So this would be 39 hundredths times 10 to the 3rd power. Bless you. Is this correctly written in scientific notation?
No.
No. So if I did standard notation, I'd say times 10 times 100 times 1,000, or the number becomes 390. Now how can I I change 390 back into correct scientific notation? Where does that decimal have to go? What?
Between the 3 and the 9.
Between the 3 and the 9. So 1, 2 places. So 3.9 times 10 to the
Second.
positive 2 or negative 2?
Positive.
Positive, because it's bigger than 10. If it's big distance, it's a positive exponent. If it's a tiny distance, it's a negative exponent. Questions?